We're going to be using the properties of logs in order to solve this log equation. So the first thing I need to do on the left-hand side is combine both of these logs as one single log since they have the same base. The base is 3. And since they're being added together, I can use the product property that says if you're adding two logs together and they have the same base, you can combine this as one single log. And you're going to do that by multiplying the arguments. So we're multiplying these two together. So the log base 3 here has an argument where we're going to multiply both of these together. So x times x squared plus 2. And eventually I'll distribute that. And that's equal to, for this log here, I notice that there's a coefficient in the very front. There's a 2 there. So I can swing that back in the exponent's position using the power property of logs. That says if you have a number in the front, you can swing that to the back and make it an exponent. So this right-hand side is 1 plus log base 3 of x to the second power. So let's go ahead and distribute on the the left-hand side here. Let's distribute the x to both terms so we can modify our argument. So this is log base 3. X times x squared is x to the third, and x times 2 is 2x. And that's equal to 1 plus log base 3 of x squared. So I do need to combine my logs and make sure they are on the exact same side of the equal sign. So I need to move this to the left side. So I'm going to subtract log base 3 of x squared from both sides. So on the left-hand side, now I have log base 3 of x to the third plus 2x minus log base 3 of x squared, and that's equal to 1. So now on the left-hand side, since I have two logs of the same base, I can combine this as one single log of the same base. And since I'm subtracting both of these, subtraction symbol, I'm going to be using the quotient property that says if you're subtracting them, you can combine them as one single log, and you're going to divide the arguments. The first argument goes in the numerator, the second argument goes in the denominator. So my argument is going to be a fraction. The numerator will be x to the third plus 2x, and the denominator will be x squared, and that's equal to 1. So to get rid of the log completely, we're going to exponentiate. Since this is base 3, we're going to be using base 3 on both sides. And so that cancels out the log because those are inverses of each other. So on the left-hand side, all you have is the x to the third plus 2x all over x squared. And that's equal to 3 to the first, which is 3. So in order to solve this, I'm going to make 3 a fraction by putting a 1 under and then cross multiply. So 3 times x squared is 3x squared. And then 1 times x to the third plus 2x is just x to the third plus 2x. So we do need to make sure all the terms are on the same side so that we can equal this to 0. So subtract 3x squared from both sides. And we are left with 0 is equal to x to the third minus 3x squared plus 2x. So I'm going to factor this. I notice that they all share an x. So I'm going to factor out an x. What's left would be x squared minus 3x plus 2. So what's left inside can still be factored. So I'm going to factor this using trinomials, saying what multiplies to 2 and adds to negative 3. And the factor pair would be negative 2 and negative 1. So my two factors here would be x minus 2 and x minus 1. So if I set all three factors equal to 0, I get 0, 2, and 1. I know that my argument cannot be 0, so if I try to plug 0 back in right here, that would be a false statement. The argument can never be 0. So I know 0 is not a true solution. And I know plugging in 2 and plugging in 1 will get me a true solution. None of those will give a negative argument. So my two solutions are 2 and 1.